there, Mega Manoa.
It's Mega Manoa, Polymer Pat.
Yeah, right. Yeah, so what are we teaching the kids today?
Well, I'm trying to do a mustard gas experiment, but I need some... oh, yes, yeah. Well, don't need that. Yeah, thank you.
So why do we need mustard? Hold on, don't get ahead of yourself. We gotta get all of our materials for today because today we're gonna do a program called Chemical Reaction, where we're gonna be playing with a whole bunch of different types of chemicals and different substances. And so be sure to grab this bag. Inside of this bag there's a bunch of things like a bottle of oil, there's a stick, bag of mustard, among other things. That's the bag that we need for today. And aside from that, these are the things that we will be needing that are not included, which are a cup of water, a pair of scissors, and a bunch of measuring spoons. Here, we definitely need a tablespoon, we definitely need a teaspoon, and a half a teaspoon and a quarter of a teaspoon. These are the measuring spoons that we need. So if you have like a whole stack together, just bring them all. But we for sure need tablespoon, teaspoon, half a teaspoon, and quarter of a teaspoon. And then finally, we need two very small cups. These are 2-ounce cups. If you guys got some of these, that'll be great. We need these small cups. Now, that being said, before we get into doing some chemical reactions, we gotta understand what chemical reactions are.
Chemical reaction, what's that?
In science, a chemical reaction is just simply when you get one chemical and you get another chemical and you mix it together. And if you get something brand new, that's a chemical reaction. And it happens all the time and everywhere, both in living things and even in non-living things. And usually when you mix it together, a lot of cool things happen. Like it might change colors, the temperature might change, sometimes it might make gas or bubbles, sometimes even things burn up or even explode. Crazy, right? But it doesn't always go that crazy, right? Sometimes it's even normal things like photosynthesis. That's a chemical reaction. Breathing. That's a chemical reaction. Even digesting your delicious pizza is a type of chemical reaction. Even lighting a candle on a birthday cake. Yeah, all of these are different types of chemical reactions. And those are very simple that we do almost every single day, right? Even what I try to take from Polymer Pat, that mustard, right? Really delicious stuff that, we could find at our local McDonald's or Wiener Schnitzel, right? Did you know that when you add a little bit of baking soda into there, there's something interesting that happens with something special in the mustard?
Something special? Like what?
Well, let's take a look at the ingredients really fast. It says there's vinegar, there's water, mustard seed, salt, turmeric, and paprika. So maybe it's that paprika. But which one do you think is the chemical that's really reacting with that baking soda?
The vinegar.
Exactly. Yep, the vinegar will react to the baking soda when you add it into the mustard. So in our next experiment, we're gonna see how that chemical reaction works when we mix the mustard with the baking soda. Here we go. Then let's make some mustard bubbles. So these are the parts that we're gonna be needing. We need the bag of powder, the blue one, the one with the blue sticker. And you also need the cup, the small cup. This came from inside of the bag. And this is optional. Get a plate because in case it does spill, it could catch it inside of the plate. Also, we need the craft stick, the mustard, and the teaspoon, 1 teaspoon, and a pair of scissors. So these are the parts that we will be needing to make our mustard bubble. So first thing you want to do is you want to take that mustard and put it inside of the cup. So how do we do that? Well, we just cut a little part to the edge of this bag so that we can squeeze it all out into here, okay? So what I like to do is I like to squeeze the edge just like that. That way the mustard is away from the edge and we can cut it, okay? Doesn't have to be super tiny cut, doesn't have to be a super big one, but just cut it so that it could open up and we could just squeeze all of that mustard out into there. Now, when you do this, it's good if you kind of twist the top. And once you twist the top, that way the mustard doesn't go anywhere else but down. And then you could just squeeze everything out and just keep twisting it, and that mustard is coming out nice and easy. Just squeeze all of it out. Or at least as much as you can. There we go. That's good. Got our mustard. And now we're gonna do the reaction where we're gonna put a little bit of this baking soda, remember, blue sticker, okay? A little bit of that baking soda, put it right inside of there, mix it together, and see the reaction. Okay, so here we go. So we're going to be using 1 teaspoon at a time, okay? And we're gonna mix it and see the reaction, and then we're gonna put another teaspoon to see if it's gonna react again. So just take your teaspoon, you can actually just reach on inside, get as much of that as you can, and put it right on top. As you can see, nothing's happening. Do you know why? Because we didn't mix it. That's what you need to do in a chemical reaction. They have to mix. Okay, so just hold the cup, get your stick, and here we go. Ready, set, and 1, 2, 3, 4, 5, and then stop, and then stop. Oh! Mustard cupcake. Not really a cupcake. Don't eat this, it's kind of disgusting. But as you can see, bubbles started to come out. A chemical reaction happened between our mustard and our baking soda. But guess what? We're not done yet. We still have some more baking soda, so you could try it again. Is it gonna work again? I don't know. Let's try. So let's get the teaspoon again. Teaspoon of that baking soda. Put it right on top. And mix it again, just for about 5 seconds, right? There you go, 1, 2, 3, 4, 5, and then stop. Okay, it's exciting, but I think I'm too excited for this, guys, but pretty cool. I mean, look at those bubbles, they bubbled up again. The reaction happened because of the special ingredient inside of the mustard, which was vinegar. When you add that vinegar with the baking soda, they react, making these bubbles. Pretty cool, right? Do you know what this is? Yeah, it's a statue of Mega Manoa.
It's the Statue of Liberty.
Yeah. Guys, that's not a statue of Mega Manoa. That's the Statue of Liberty. And the Statue of Liberty is made out of copper, just like this penny. And if you take a look at it, it looks kind of green now, but it wasn't always like that, especially when they brought it over about 130 years ago. It looked more metallic brown. So what happened? The birds poo-poo all over it and it turned green? Why are we even talking about that? That's gross. That's not what happened, guys. Instead, chemical reaction. If you don't get it, that's what we're talking about today. Come on, guys, chemical reaction. Yep. a chemical reaction happens between this piece of copper, which is this penny, and the air that is around it. Okay, so once the air comes in contact with our copper, like the penny and the Statue of Liberty, something interesting happens. It creates a very thin layer of green copper oxide. Okay, but underneath it, it's still copper, it's still metallic brown, but just on the surface, it makes this green layer, okay? And that's what happened to our Statue of Liberty. So, we're gonna do something even weirder. We're gonna undo this copper oxide reaction by doing our own chemical reaction. What? Then let's take off that green layer of copper oxide off of our penny. Take a good look at it, because in just a little bit, it'll be transformed into something brand new looking. Oh, it might not be that amazing, but let's do the experiment, guys. And these are the things that we need. We need the bag of powder with the red sticker, yellow sticker. Inside of here is vitamin C. Inside of here is salt. The stick, again, what I did was I just cleaned it off. If you don't want to do that, you could just use one of your measuring spoons, any other spoon to mix together. We do need the 2 little cups. Again, these were not included. Just take 2 tiny cups. And again, this one's optional, a plate again, just in case there's some spills. Of course, we need the penny, the cup of water, and the tablespoon. This is the only measuring spoon that we're going to be needing. And so let's piece this together. All right. So we're just going to take a little bit of that water and put it into one of your cups. We're going to take 2 tablespoons into the cup. So just take that, pour right in there. Here's 1, and here's 2. Okay. Then what we're going to be doing is getting some of the vitamin C, the red sticker bag, putting it inside of that same cup that has the water inside. And just pour all of it. After you do that, get your mixing utensil, like the stick or the spoon, whichever one, and just mix that up. So vitamin C is a type of acid, okay? And this, together with the salt, is gonna make a reaction that's gonna do something to our penny. But for now, it's just vitamin C, a little bit of an acid. And let's put the penny inside and see if it does anything. Okay, so we're just gonna take our penny, put it inside, and nothing happens, guys, because there's no chemical reaction. Even if I mix it, nothing, still looks the same. Yeah, even if I mix it, nothing much happens to my penny, nothing. But once we get a little bit of the salt, which is a type of base, mixing with this acid, the chemical reaction is for sure gonna happen. And let's see what happens after that. So get your salt afterwards and pour it right inside of there. And well, now, like the other experiment, we have to mix it to make the chemical reaction. So let's mix this for just about 10 seconds. 1 and a 2 and a 3 and a 4 and a 5 and a 6 and a 7 and a 8 and a 9 and a 10. So again, when we mix the salt, which is a base, the vitamin C, which is an acid, that makes a chemical reaction, which is actually going to eat away or dissolve at the green copper oxide that was on our penny. And the way I like to take it out, it's a little bit hard and challenging, is with this stick. I like to stick it under, or you can just use your fingers, but I'm gonna use this stick to try to pick it out. And it looks a lot cleaner. That's crazy. And what happened? Again, the chemical reaction that happened when you mixed the salt with the vitamin C dissolved the copper oxide that was on the surface of our penny, and what was left is the copper that is already there in our penny, right? Technically, you don't need the second cup, now that I realize, but just put your penny inside of it if you want to. But take a look at that. Maybe try it with other pennies that you have at home. Try the same little tiny chemical reaction. As we have already talked about, chemical reactions can be in all sorts of forms and sizes, like explosions, right? Or changing of colors, temperatures, right? Among many different things. But this time, we're going to make a chemical reaction happen from mixing a solid with a liquid to make gas from our very own lava lamp. Whoa! Not that type of lava. This type of lava lamp. Then let's make our lava lamp that is not hot like real lava, thankfully. These are the parts that we're going to be needing. A cup of water again, that tablespoon, the bottle of oil that came from inside of the bag, the bag that has the tablet. Yours might be broken up, might be 2 pieces, 3 pieces, or 1 piece, just like mine here. And this little tiny color tablet. This also came inside of the bag, so hopefully you didn't drop it somewhere, okay? So just look out for this guy. It just changes the color, okay? Then we want to basically put some of the water into our bottle of oil. Now you don't want to overfill this, okay? You want it to go just to about where it starts to curve, right under that. Give yourself a little bit more room than that, okay? But you don't want to go past that, because once the reaction happens, it might spill over, in which we don't want that to happen, okay? So we want to put a little bit of water at a time and just kind of look at it to make sure it doesn't pass that the part where it starts to curve, okay? So open this up. Now be very careful with this. Hold it nice and tight, because you don't want to spill it. This stuff is kind of hard to clean up. This is oil. Okay, so be very careful how you hold this and making sure that it doesn't spill. Get a little bit of that water and start putting it inside, a little bit at a time, okay? And after you do one, check to see if it's getting close to there. Okay, we still have a little bit of room to add some more water into this. So I'm gonna add a little bit more water into mine. And here's my second scoop, okay? And I didn't use the full amount of my second scoop because I'm starting to get to the part where it starts to curve, and we wanna go under that, okay? We don't want it to overfill too much, but this is good enough, okay? So once that happens, let me just close it so you guys could see what's going on here. So we see that I just put in some water. The water's on the bottom. Right above that is the oil, and they're not mixing, but we can use this to our advantage. Okay, we're gonna change its color first off so that we can clearly see the water, and then once we put this in, a really cool chemical reaction is gonna happen in just a second. But first, let's change the color of the water. So keep it open, take the little color tablet, put it right inside, and you'll see that that is gonna start mixing together with the water, and it's gonna change the color of what's going on in the bottom. Now, before we even do anything else, there's one thing I do wanna warn you is do not shake it. Don't shake it. Okay, because you're gonna have to wait for a while for the water to separate from the oil again. But we need it to be separate, just like how you see here, so we can see the chemical reaction happen when the tablet, the Alka-Seltzer tablet, goes into our water. Okay, so now is when we're going to finally put this Alka-Seltzer tablet into there, and it's gonna react to the water, causing some bubbles, a chemical reaction, okay? So as you can see, not really much is happening, right? Not until you put this in. It's gonna mix together, and it's gonna make a lava lamp. So here we go. So if you have one big piece, put it in. If you have smaller pieces, you could put it in one at a time. We could put all of it in at the same time, but here we go. Okay, and then close it quick, close it quick, close it quick. And take a look at that. Whoa. See it bubbling up? See that? That's crazy. Look at that. So the tablet is reacting with the water inside, causing some bubbles. That's a chemical reaction. And then the bubbles going up, 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 up. But it's more dense than the oil, so the bubbles come back down. It's just bubbles of water and mixed with a little bit of air, and it's coming back down to the bottom, causing it to have this lava lamp effect. That's pretty cool, right? If for some reason you couldn't find the color tablet or it was missing somewhere, just use food coloring to change the color that's even better because you could choose whatever color you want. But eventually we're gonna run out of the tablet, and there's a cool trick I'm gonna show you in just a second as to how to make it react again. But you guys can do this forever. All you need to do is just ask mom and dad to get you some Alka-Seltzer tablet. You can do it over and 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 over again as much as you want. As long as you have some Alka-Seltzer tablet, this will continue to work. But again, like how I said earlier, eventually it's gonna stop working. It's gonna stop reacting because it's ran out of the tablet. And a cool way to make this go again is just open it, untwist it really fast, and twist it back on right away. So it's like less than a second. It's like just a flick of the wrist really quick, just like this. So watch, ready, set, see that? It was quick. Now look at that. You heard the little burst of air coming out? It was really quick. And then I closed it, but you can see the reaction is happening again and again and again. But again, a better way to do it is just get some more Alka-Seltzer tablet. But again, look at that. That is pretty awesome that we were able to make something like this. Whoa, we had way too much fun. Especially with this lava lamp. I love this. I hope you guys love this and all of the chemical reactions that we did today. Thank you again for joining us today, and until next time, I'll see you at home.